Dear student, myself Rajendra Aaseri. I am assistant professor in computer science department at Government Pangad PG College, Didwana. In the previous lecture, we have discussed various concepts about cryptography and network security. We have discussed about some basics like what is plain text, how to convert a plain text into ciphertext, what is encryption algorithm, what is decryption algorithm, some theorems on modular arithmetic like Euler theorem, Fermat's theorem, prime number concept, how prime number is helpful in ensuring the security of the cryptographic algorithm. All these concepts we have discussed. We have discussed various cryptographic technique like substitution technique and transposition type of technique. Monoalphabetic type of cipher we have discussed and polyalphabetic also. In stream and block cipher, what are the various significant differences, how to implement both of these, we have discussed this. The ingredient of a basic crypto system we have discussed like plain text, ciphertext, encryption algorithm, decryption algorithm, public key, private key, and the channel. Clear? In symmetric and asymmetric, what are the differences? Where, in which scenario symmetric is applicable, and in which scenario asymmetric cryptography is helpful? All these concepts we have discussed in detail. In the previous lecture, we have discussed about public key cryptographic concept and how this public key cryptography is helpful in ensuring the authentication and encryption. Means with help of public key cryptography, we can perform or we can implement the concept of authentication. We can ensure the authenticity of sender and receiver. Clear? And with the help of public key cryptography, we can ensure the encryption or security of the algorithm also, right? So in today's lecture, we will be focusing on a very popular algorithm, RSA crypto system, right? So RSA, how RSA name comes into picture? So basically it is given by three scientists, Rivest. So from Rivest name R is taken. Second scientist name is Samir, S is taken, and Edelman. So from that A is taken. So RSA name was popular for this particular algorithm. So Rivest, Samir, and Edelman of MIT discovered in 1977. It is very well known and widely used public key scheme. Public key cryptography scheme means in this algorithm there are two type of keys are used. One is public key and one is private key. Clear? It uses large integer. One integer size is equal to 1024 bits. It means total possible combination. Suppose I have one bit, then total two possibilities there, either 0 bit or 1 bit. If I am having 2 bit, then total 2 power 2 4 bits, 4 possible combination, 0 0 0 1 1 0 and 1 1. If I am having 3 bits, then there are total possible combination is 2 power 3, that is 8, like 0 0 0 0 0 1 0 1 0 1 0 0 0 1 1 101 110 and 111. Clear? So similarly here the integer size is 1024 bits. It means total possible combination will be 2 power 1024. So it is we can say hardly impossible. It is very impossible to crack this RSA crypto system. Clear? Now, how to implement this RSA crypto system? So in RSA crypto system, first we need to generate private key and public key. After that, we need to implement encryption algorithm. Then at the receiver end, we need to perform decryption algorithm, right? So first we are generating key. So key generation process is the first process in RSA crypto system. First thing, first step is we need to select two prime number, very large prime number we need to select, P and Q. First step. After that we need to calculate. After that we need to calculate the multiplication of both these number. So calculate n equal to P into Q, right? Third point is calculate a Fermat quotient function phi n, And if a number is prime, then the Fermat quotient function, suppose p is a prime number, so Fermat quotient function will be phi of p is equal to p minus 1. Clear? So if I'm saying I have a prime number n equal to 5, so phi of 5 is equal to 5 minus 1 is equal to 4. So phi of 5 is 4, phi of 21 is not a prime number, so directly we cannot calculate. We need to find factor of a prime number. So if there is a number, composite number, so in case of prime number, the Fermat function will be phi of n is equal to n minus 1. In case of composite number, we need to calculate factor of that composite number, and composite number should be factorized in such a manner that all the factors should be prime number, right? Suppose I am saying 21 is a composite number, so I need to factor in 7 and 3, and 7 and 3 both are prime number. So phi of 21 is equal to phi of 7 into phi of 3, and phi of 7 is phi of 7 minus phi of 7 is 7 minus 1, and phi of 3 is 3 minus 1. So 7 minus 1 is 6 and 3 minus 1 is 2. So 6 into 2, 12. Phi of 21 is equal to 12. Clear? So third step again come to the third step. Phi of n is equal to n. What is the value of n? N is equal to p into q, and p and q both are prime number. It means phi of n equal to phi of p into phi of q, right? We can distribute Fermat function on multiplication. It is distributive on multiplication process, right? So phi of n is equal to p minus 1 into q minus 1. Now we have to select integer e such that GCD, greatest common divisor of whatever we have calculated in the previous step. What was that? Phi of n. So GCD of phi of n, calculated phi of n, and this e should be equal to 1. Means they should be co-prime. Co-prime means both two numbers are co-prime if GCD of both the number is equal to 1. Suppose I am taking an example. First number is 3, second is 5. So 3 and 5. So 3 and 5 GCD greatest common divisor of 3 and 5 is common divisor is only 1. So GCD of 3 comma 5 is equal to 1. It means 3 and 5 are co-prime number, right? So in fourth step, again coming to the fourth step, we need to select integer e in such a manner that if we calculate GCD of phi of n, Fermat function of n, and phi of n is equal to p minus 1 into q minus 1 comma e, then it should comes 1. It means phi n, calculate phi n and e. E should be selected in such a manner that it should be co-prime with phi n, right? So and phi n it will e will be greater than 1, definitely greater than 1. It cannot be in point, so greater than 1 and less than phi n, right? Because we want to calculate e in such a manner that it irrespective of the phi n, it should give the GCD 1. Fifth point is now calculation of digit integer d will be done in such a manner that d should be inverse of multiplicative inverse. Which type of inverse? Multiplicative inverse of the selected e value. E inverse in under the mode of phi n, right? So d integer d will be calculated from e. How? Inverse, multiplicative inverse of e under mode phi n. Then it will be given to the d value. So d is calculated. So up to this point, first step we selected p and q. Second step we calculated multiplication n equal to p into q. Third step we calculated phi of n equal to p minus 1 into q minus 1. Fourth step we selected integer e which is co-prime to the with respect to phi n. Fifth point we have calculated d integer that is multiplicative inverse of e under the modulus phi n. Sixth point is public key. So here e we know, n we know. So e and n in combination will act as a public key, and d and n in combination will act as private key. So this process, first process we have done, first step, that is key generation, we have done. Now next step is encryption and decryption and key generation. All these three steps has been explained in this particular picture. So step by step we are learning. First, the component of this algorithm is Alice. Second component is Bob. Alice is sender and Bob is receiver. Now here at sender end we are performing what? Encryption. At the receiver end we are performing what? Decryption. Now this step is key generation step, first step. This is encryption step, and the third one is decryption step. So first step is key generation. First step is key generation. So how to perform key generation? Again I am taking marker. Now in key generation, Alice is the sender. Now we have P, plain text. Plain text, with the help of plain text we can do what? Encryption. So rather than doing encryption first, what we are doing first? First we are doing key generation. So in key generation we require two large number P and Q, large prime number. Then second step we are calculating what? N, that is equal to P and Q. Then we have to select E and D. E is a co-prime number with respect to n, and D is multiplicative inverse of E under modulus of phi n, right? So if you notice, a group is there. So in key generation step we calculate E and D. Now if you see, it is a G in which it is a set Z of phi n star. Phi n star means it should contain the numbers which are multiplicative inverse, or every number is having a multiplicative inverse in the group and a value x under the multiplication process, right? So once we created E and D, E is public key and D is private key. So first step, key generation step has been done. E is public key and D is private key, right? Now next step is encryption step. In encryption, what we are doing? We are taking plain text and public key. With the help of that, we are performing what? Encryption. So starting from second step is encryption, right? So we are having plain text. Sender Alice is having a plain text. Plain text is given as input to the encryption algorithm, and we are having what? Public key. So public key and plain text, public key and plain text both are given to the encryption algorithm, and in encryption what we are doing? We are generating a ciphertext C. So C will be equal to plain text, we are applying encryption key on it, P raised to E exponential A E, and then under modulus what? Under modulus n. So plain text and E we are having. E we have generated in first step, key generation step. Plain text, so on plain text we are applying encryption key, public key, and with help of that we are doing what? Modulus n. Then it will generate what? Whatever it is generating, that will given to the C, that will act as the ciphertext. Clear? So in this manner C has been generated. Now this C is ciphertext will be forwarded in the insecure channel uh, to the receiver, right? At the receiver end, receiver is getting what? C, and actually he wants to get what? Plain text P. So means at the receiver end decryption algorithm will be applied. Now in the decryption algorithm, first input is the C ciphertext and second input is the key. Now in encryption algorithm, public key encryption algorithm, for the encryption we are using what? Public key, and for the decryption we are using what? Private key, right? All of you know this. In the previous lecture I explained. So we are having what? Ciphertext first input, and second input is D, that is private key. What is D? D was equal to E of E inverse, multiplicative inverse of E under modulus phi n, right? So D and C both we are having. So we are calculating what? P. How to calculate P? We are having C, applying D on it, and mod n. So if you apply mod n on C power D, then it will result into P, that is plain text. So in this manner we can perform key generation, encryption and decryption. All these three steps can be done step by step. Okay, now we are taking an example that how to perform RSA crypto system in real life. So suppose Bob chooses 7 and 11 as prime number P and Q. So P value is 7 and Q value is 11. So we are having P and Q. So first step in RSA crypto system is key generation. For key generation we require two prime numbers. So here prime number value is P equal to 7 and Q equal to 11. Now we have to calculate what? N equal to P into Q, that is here 7 into 11, 77. Third step is calculate phi n, format quotient function, right? So phi of n is equal to P minus 1 into Q minus 1. P value is 7, so 7 minus 1 is 6 and 11 minus 1 is 10. 6 into 10 equal to 60. So phi of n we have calculated. Now Bob chooses two exponent E and D from Z60 star. Z60 star means Z phi n star. And what is phi n value? 60. Z60 star means in Z60 there are 60 members, but out of 60 members, all are not having a multiplicative inverse. Clear? So Z60 is set of integer starting from 0 to 59, and Z60 star is set of integer from 0 to 59, not including all the integer but including only those integer who are having multiplicative inverse under Z60, right? So Z60 star, under Z60 star we selected E and D. Now Bob chooses E value if 13, then D value will be 37. Why? Because E is 13, which is definitely co-prime to the 60, because phi of n because GCD of 60 and 13 is equal to 1. That's why E can be 13. Then D value will be equal to 13 inverse mod 60, right? So in this manner it will give the value 37. We can calculate this D value multiplicative inverse of E. Here E is 13, so under phi n is 60. So 13 inverse mod of 60 will be 37. With the help of Euclidean algorithm we can find multiplicative inverse of any number under any mode, right? So here E into D mod 60 is equal to 1. It means E and D are multiplicative inverse of each other. Now imagine that Alice wants to send the plain text 5. So P value is 5 to Bob. So now plain text value is, if you see, plain text value is 5. C. How to calculate C? C was calculating P power E mod n. So P value is here 5, E value is 13, mod n is 77. If we do, we perform, then 26 mod 77 we are getting. By simplifying we will be getting what? 26. Where under mod 77, 26 mod 77 is equal to 26. So C value will be 26. P value was 5 and C value is 26. Now at the receiver end, Bob received the ciphertext 26 and uses the private key 37. 37 we have calculated. E was 13, right? Now see, C was 26, D value is 37. So how to calculate P? P is equal to C power D mod under what? N, right? So put the value. C value is 26, mod power 37. If you do mod 77, then after simplifying 5 mod 77, so result will be, plain text will be 5. So in this manner we can perform RSA crypto system. Thank you.